part 2 of solving inequalities, graphing, and writing the interval notation. So if you haven't watched part 1, where I introduced this subject, please, I recommend you do if you have time, because it's going to make you understand this part 2 even better. So what if we're given an inequality like this, right? They're giving you 3 minus brackets 2x minus 7 close brackets. Now this is less or equal to. Every time you see a less or equal to, the first thing that should come to your mind is we're going to be using square brackets, unless we have an infinity, of course. And we're going to be using our dot, and it's going to be a full complete dot. Anyway, so moving on, less or equal to 34 less 6x. Our 3 rules are still going to apply. The first is distribute. But remember, we're going to be distributing with a -1 here. So we're going to distribute collect like terms out the value of the unknown. In this case, it's x. So to distribute, I'll be getting 3 minus 2x plus 7 is less or equal to 34 minus 6x. Of course, this side, I'm seeing a 3 and a 7. Those are like terms. Those are both constant. So they can join or combine and make 10. So it will be 10 minus 2x is less or equal to 34 less than 6x. All right, so I want to take plus 6x, right? Negative 6x plus 6x, this cancels. So these two terms cancel. So at this point, I'll be having 4x less or equal to that 24. Here, I'll divide both sides by 4, and then I'll get x is less or equal to 6, right? So x has to be less or equal to 6. Think about it. Give me any numbers that are less or equal to 6. So it could be 6, right? It could be negative 2,000, right? So I'll just come to my number line or graph, or whatever you choose to call it. So if I have maybe 6 here, 5, 4, 3. So I'm just interested in 6 anyway. So this number line, these arrows mean this goes on up to negative infinity, and this other arrow means this goes on up to positive infinity. So because I'm dealing with less or equal to, that means I'll go to 6 and use a full dot, right? Shade it out. And then I will indicate which side is less or equal to. Is this side? No, this side is greater. So this side less or equal to, I'll say, so anything in that range is actually part of the solution set. So I'll write the notation as the lower limit is negative infinity. So negative infinity. Every time you're using infinity, please use parentheses, right? So negative infinity, and the upper limit is 6. And because we're using less or equal to, I'll use the square bracket. That is the interval notation. Really, really interesting. Please feel free to pause this video and try out this problem. Like I said, also, if you haven't watched part 1 of dealing with these inequalities, go back, watch part 1, and things will make much more sense. All right, other than that, let's look at the last example. So, like I said, from my video 1, every time you see parentheses, the first thing you need to do is distribute, collect like term, and what? So, and we're saying greater or equal to. What that means is square bracket, full dot. But let's first, distribute. So we're having our 5x. So we're distributing this with a negative 3. So minus 3x minus 18 is greater or equal to 8. We're distributing this negative 1. So 8 minus x plus 7. So if negative 1 multiplies with x, we get a negative x. If negative 1 multiplies with negative 7, we get a positive 7. So just look at these two sides. This is xx. We don't want that. We want only one x, right? So 5x, negative 3x, those are like terms. So 5x minus 3x, you'll get a 2x. So 2x minus 18 is greater or equal to, you see 7 and 8 are like terms. So 7 plus 8 will give you 10. This side will be left with 3x greater or equal to negative x plus x would cancel. So you see how I'm left with 3x greater or equal to 33. Please feel free to pause this video and do work out your steps. It doesn't matter if you want to move one variable at a time, move one constant at a time, that's fine. You'll still get the right answer. And if you missed my series from 1 where I was teaching single-step equations, 2-step equations, please, and you feel like you need it, go back to those series and watch those videos. I explained how we deal with 1-step equations, 2-step equations, multi-step equations, and this will, make more sense. But if you're still on the same point as what I'm doing right now, please let's continue. Dividing both sides by 3 will get rid of this coefficient. This cancels. So I'm having my x being greater equal to 11. Think about which values are greater or equal to 11. Also, this would make x the lower limit of my interval because x wants any value greater or equal to 11. So 11 is the lower interval. Start from 11. 12, 13, 100, a million, So anything greater or equal to 11 will be part of my solution set. So I'll go to my graph. This is 13. I'm just interested in 11 anyway. So I'll just go to my 11. Question is the dot going to be complete or just space? Look at that inequality. It's greater or equal to, so it's going to be complete. So just go to 11 and make a full complete dot like this, right? And anything greater or equal to 11 will be part of the solution set. So to write the interval, I'll write 11, and then I'll use what kind of brackets? Will they be square or parentheses? So they'll be square because we're dealing with greater or equal to, so 11, so up to positive infinity. But every time we're using infinity, we use these parentheses. So that should be the interval notation. All right, guys, thank you for watching my video, and see you again in my next video.